Tonight, we dismantle the most absolute border in the known universe to discover that the point of no return may be the greatest illusion ever told. Imagine a doorway that does not actually exist until the very end of time. For decades, we have been comforted by the vision of the event horizon as a clean, mathematical line where space ends and mystery begins. We were told that if you crossed it, you would simply fade away, a silent ghost trapped by the relentless, predictable grip of gravity. But what if that boundary is a lie? What if the edge is not a physical place you can touch, but a mathematical ghost of a future that has not happened yet? Beneath the steady silence of the cosmos, a war is being waged between our greatest theories, and the smooth crossing we were once promised has been replaced by a landscape of fire, quantum-tangled webs, and computational barriers so complex they defy the age of the stars themselves. If you thought you knew what happened at the edge of a black hole, prepare to let that certainty drift away, because tonight, the border is vanishing. To understand how we have been misled, we must first return to the comfortable myth of the border. For nearly a century, the event horizon has been sold to us as the ultimate cosmic prison, a perfect, dark sphere floating in the void. We are taught that it is a one-way membrane, a point of no return where the escape velocity finally exceeds the speed of light. In this classical view, the horizon is a quiet, steady marker between what can be known and what is lost forever. It is defined by the Schwarzschild radius, a precise mathematical distance from the center of a collapsed star where space and time become so severely warped that every possible path leads only inward. There is a certain peace in this definition. It provides a clean, geometric edge to reality, a sharp division in physics between escape and permanent capture. We imagine it as a silent threshold that does not flash warnings or make noise, but simply exists as a geometric consequence of gravity. The textbooks tell a story of no drama. They suggest that if you were to drift toward a supermassive black hole, the crossing would be entirely unremarkable. Because the gravitational gradient of such a massive object is so gentle at the horizon, your body would feel no immediate discomfort, no sudden jolt, and no change in the vacuum of space. You would look at your watch and see the seconds ticking by normally. You would pass through the horizon without even realizing you had left our universe behind. This smooth, uneventful transition is a cornerstone of Einstein's general relativity, the idea that the laws of physics should remain consistent and predictable even at the most. Extreme edges of the cosmos. It is a narrative of continuity, a promise that space is smooth and that the point of no return is merely a coordinates-based illusion that only matters to those watching you from a safe distance. But this quiet picture is a lie that covers up a much deeper, more disturbing truth. Modern physics has turned this neat textbook image into a battlefield, and the first casualty of this war is the idea that the event horizon is a physical thing you can actually find. We have been led to believe that the horizon is a local line in space, like a border between two countries. But the deeper reality is what theorists call the teleological illusion. A true event horizon is globally defined, which is a polite way of saying it is a mathematical ghost. You can only know exactly where an event horizon is by knowing the entire future history of the universe all the way to the end of time. This is where the comfort of the border begins to dissolve. If you were standing at the edge of a black hole right now, there is no experiment you could perform and no instrument you could build that would tell you that you are at the horizon. Locally, the space there is indistinguishable from empty space anywhere else. The horizon only exists if, in the infinite future, you never manage to send a signal out to the rest of the cosmos. This means the event horizon is not an object, it is a mathematical bookkeeping tool that nature uses to track what might happen in the future rather than what is happening in the present. It is a boundary defined by future infinity, an eerie realization that the most famous structure in astrophysics isn't even a physical reality in our current moment. This revelation suggests that we have been looking at black holes the wrong way. We treat the horizon as a barrier that prevents information from returning, but what if the barrier is actually one of complexity rather than gravity? This is the computational horizon theory, an overlooked detail that original documentaries almost always ignore. It suggests that the reason you cannot return from a black hole is not just because space is curved, but because the information that makes you becomes scrambled into a level of complexity so high that it would take longer than the lifespan of the entire black hole to decode it. Nature is not just trapping you, it is hiding the truth of your existence behind a computational wall. The point of no return is effectively a practical limit of complexity. Like a hard drive that is technically solvable but physically inaccessible, the horizon is a mirror reflecting the broken limits of our own models. Even more disturbing is the realization that the event horizon might not even be a permanent structure. Stephen Hawking famously suggested in his later years that true event horizons may not even form. Instead, we might only have apparent horizons, temporary regions where light and matter are trapped for a time, but eventually released. If this is true, the entire concept of a point of no return is a misunderstanding of cosmic proportions. It means that nothing is ever truly lost forever. It is merely being held in a state of extreme complexity until the black hole eventually evaporates and releases its contents back into the void. The absolute isolation we associate with black holes might be a temporary illusion, a ghost boundary that we have mistaken for a physical wall. This creates a psychological tension that the original outlier videos completely missed. They focus on the scale horror of being crushed or the time dilation of being watched. But they ignore the deeper scale horror, that you could be inside a black hole right now and not even know it. Because the horizon is teleological and defined by the total future, there is no way to verify your own position within the causal structure of the universe in the present. The comfortable myth of the border was designed to give us a sense of order in a chaotic universe, a way to mark where here ends and there begins. But as we peel back the layers of Schwarzschild geometry and Einstein's peaceful lie, we find that the border is a battlefield where our theories of reality begin to disagree. We were wrong about the event horizon because we wanted it to be simple. We wanted a clean line. We wanted a point where the math stopped and the mystery started. But the deeper we look, the more we find that the horizon is an active, violent, and highly complex surface that challenges the very idea of what is real. It is where general relativity's smooth geometry crashes into the jagged, fiery world of quantum mechanics. It is where information is encoded, scrambled, and perhaps even destroyed. As we prepare to journey deeper into the heart of this mystery, remember that the point of no return is not just a destination. It is a mirror reflecting the fact that our most foundational knowledge of the universe is built on a border that might not even be there. To understand why we have been so profoundly mistaken about the edge of the abyss, we must first look at the quiet mathematical architect of the void, a man named Karl Schwarzschild. While the world was tearing itself apart in the trenches of the First World War, Schwarzschild was looking into the heart of Einstein's new equations of gravity, searching for a perfect, clean solution for the space surrounding a single point of mass. What he found was a number, a critical distance that now bears his name, and with that number, he unknowingly built the most absolute prison in the history of human thought. This is the Schwarzschild radius, the precise mathematical distance from the center of a collapsed star where the fabric of space and time becomes so severely warped that every possible path, every future, and every beam of light leads only in one direction, inward. It is the sharpest division in all of physics, a geometric line drawn in the sand of the universe between the possibility of escape and the certainty of permanent capture. There is a strange, unsettling peace in this mathematical certainty. In our mind's eye, we often imagine the event horizon as a swirling, violent storm of fire and chaos, but the physics tells us something much steadier and more patient. For a non-rotating black hole, the Schwarzschild radius defines a perfect sphere, a silent, dark shell floating in the vacuum of space. It is not a surface you can touch, nor a membrane you could feel. It is simply a location where the structure of spacetime changes its character. It does not flash warnings or make noise, it just exists as a gentle marker between where light can still outrun gravity and where it cannot. If you were to replace our Sun with a black hole of the exact same mass, the Schwarzschild radius would be a mere 2 miles, and the Earth would continue to orbit it just as it does now, undisturbed and unaware that the Sun had become a perfect sphere of entrapment. This is the perfect sphere of the textbook black hole, a structure that follows the rules of the universe with mathematical precision. The bigger the monster, the bigger the cage it builds for itself. If you double the mass of a black hole, you double the size of its boundary, scaling these cosmic prisons with a consistency that shocked the scientists who first calculated it. For a supermassive black hole, this radius can stretch across distances larger than our entire solar system. Yet even at that scale, the boundary remains as sharp and well-defined as a razor's edge. We are comforted by this predictability. We find rest in the idea that even in the most extreme corners of existence, there is a stable, persistent structure that does not flicker or change its mind. It is the ultimate one-way door, an invisible frontier that separates the universe we know from a void that can never be reached. However, this calm stability is where the misunderstanding begins to take root. We treat this sphere as a physical object, a boundary as real as the surface of a planet or the wall of a room. But when we lean closer, the no-drama prediction of general relativity offers us a disturbing secret. The event horizon has no thickness, no friction, and no resistance. If you were drifting toward the horizon of a supermassive black hole, your experience would remain entirely unremarkable. You would pass through the Schwarzschild radius without any sudden jolt or sensation of crossing a border. Your watch would continue to tick normally, and your body would feel no unusual forces, as if the most absolute barrier in the universe were nothing more than a ghost of a coordinate system. This is the central paradox of the event horizon. It is the most significant location in the cosmos from the perspective of an outsider, yet it is a non-event for the traveler. Who actually crosses it? This leads us to a question that begins to dismantle our sense of reality. Is this most absolute barrier in physics actually real? In the classical view, the Schwarzschild radius is the ultimate fact, but in modern theory, the horizon is beginning to look like a teleological illusion. A true event horizon is globally defined, which means its existence depends on the entire future history of the universe. You only know you have crossed a horizon if, in the infinite future, you never manage to send a signal back out to the stars. If you were standing at the edge of a black hole right now, there is no experiment you could perform. Not with light, not with matter, not with any instrument human hands could build. That would tell you that you are at the point of no return. Locally, the space there is indistinguishable from the empty space you are sitting in right now. This realization transforms the event horizon from a physical object into a mathematical bookkeeping tool. It is a boundary defined by future infinity, a ghost of a timeline that hasn't happened yet, tracking what might be trapped rather than what is actually happening in the present. Moment. We have spent a century imagining a physical wall, a dark sphere of entrapment, but we may have been looking at a mirror of our own mathematical models. If the horizon is not a physical surface, but an emergent feature of a future we cannot see, then the very concept of a point of no return begins to dissolve. It suggests that the edge of reality is not a fixed place, but a vanishing border that only exists as long as we believe our current theories are complete. The perfect sphere of Schwarzschild is a masterpiece of geometry, a calm and stable vision of the void that allows us to sleep with the certainty that we understand the limits of our world. But if this barrier is not a physical place you can touch, but a computational limit or a holographic projection, then we have been profoundly wrong about what it means to be lost. As we drift into the next layer of this mystery, we must confront the possibility that the most absolute line in the universe is not a destination at all, but a mathematical shadow, a ghost at the edge that we have mistaken for a wall. To understand why our vision of the universe is fracturing, we must confront a concept that feels more like poetry than physics: the teleological problem. In our everyday lives, we are used to boundaries that are local and immediate. If you walk into a wall, you feel it in that exact moment. If you cross a river, the water splashes against your skin as you move. But the event horizon is not like a wall, and it is not like a river. Modern theoretical physics has revealed that a true event horizon is globally defined, which is a polite way of saying it is a mathematical ghost that does not actually exist in the present moment. It is a structure that depends entirely on the entire future history of space-time, reaching out to the very end of time itself. Because of this, you can never truly touch an event horizon in the present, because its very existence hasn't been finalized yet. Imagine you are drifting through the silent, dark reaches of space toward a massive black hole. You have been taught to fear the point of no return, that invisible line where gravity becomes absolute. You check your sensors, you look for a ripple in the fabric of the void, but you find nothing. This is the eerie heart of the mystery. Locally, it is impossible to detect an event horizon. There is no experiment you can perform, no instrument you can build, and no flash of light that will tell you the exact second you have crossed the threshold. The space at the edge is indistinguishable from the empty space you left behind millions of miles ago. You could be crossing the most significant border in the cosmos, and your body would feel only the same weightless drift it has felt for days. This is because the event horizon is teleological. It is defined by its end. To know if you are currently inside an event horizon, the universe would have to look forward through every second that will ever occur, across billions and trillions of years, to see if you ever manage to send a signal back out to the stars. If, at any point in the infinite future, a single photon from your flashlight escapes the gravitational well, then you were never behind a horizon to begin with. But because that eventually requires the history of the universe to be complete, the horizon remains a mathematical bookkeeping tool rather than a physical object you can encounter in the now. It is nature's way of tracking what might happen in the future rather than what is happening in your present. This realization creates a profound sense of psychological tension that the simple trapdoor documentaries completely ignore. If the horizon is only defined by the total future, then you could be inside a black hole right now and not even know it. Our reality is governed by a causal structure that we cannot verify in the moment. We are comforted by the idea of the point of no return as a destination we arrive at, but in truth, it is a ghost of a future that has not happened yet. On a Penrose diagram, the maps physicists use to chart the infinite reaches of time and space, the event horizon appears as a diagonal line that stretches all the way to future. Infinity. It is a boundary that exists only when the story of the universe is over. We have spent decades looking at the event horizon as a physical wall, a dark sphere of entrapment that marks where a black hole is. But as we peel back the layers of our misunderstanding, we find that we have been mistaking a prediction for a reality. The horizon is a calculation, a shadow cast backward from the end of time onto the present. It tells us that our most foundational knowledge of the universe is built on a border that might not even be there in the way we imagined. It is a vanishing border, a mathematical artifact that exists in our models but refuses to be touched by our hands. This ghostly nature of the edge is what allowed Stephen Hawking to eventually suggest that true event horizons may not even form at all. If the universe itself does not last forever, or if black holes eventually evaporate and release their contents, then the point of no return was never truly absolute. In that case, what we thought was a permanent prison was actually just an apparent horizon, a temporary trap that eventually lets everything go. The absolute isolation we associate with these cosmic monsters becomes a temporary illusion, a misunderstanding of a boundary that we thought was a physical wall, but was actually just a long, complex pause in the flow of information. Think of it as a cosmic hard drive that is technically solvable, but physically inaccessible. The horizon is not blocking you with a physical force. It is hiding the truth behind a level of complexity so high that it would take longer than the life of the stars to decode. Nature is not just trapping you, it is using the very structure of time and complexity to create a barrier where our theories begin to fail. The point of no return is not a physical place you can visit, it is the limit of our own ability to model the future. It is a mirror reflecting the broken limits of human certainty. As you drift deeper into this thought, the silence of the void feels a little more heavy, and the darkness a little more layered. You are moving through a region where the point of no return is a coordinates-based illusion that only matters to the distant observer watching you fade. To you, the traveler, the edge is a ghost. You pass through it and realize that the most famous structure in the universe isn't even a physical reality in your current moment. You are falling into a mathematical shadow, moving toward a center that we can only guess at, because the boundary that was supposed to define it has vanished into the math. This is the teleological trap. We wanted a clean line where the math stopped and the mystery started. But the deeper we look, the more we find that the horizon is an active, violent, and highly complex surface that challenges the very idea of what is real. It is the place where Einstein's smooth geometry crashes into a world of jagged quantum fire. And as we leave the comfort of the ghost behind, we must prepare to face the reality of what happens when that smooth crossing is replaced by something much more dangerous. To understand why we have been so profoundly misled, we must abandon the distant view of the mathematician and step into the experience of the traveler. Imagine you are suspended in the center of a silent silver cabin, drifting through the deep, velvet reaches of the cosmos toward the heart of a galaxy. You are approaching a supermassive black hole, a monster millions of times heavier than the sun, yet one that behaves with a grace and patience that contradicts every violent illustration you have ever seen. As you move closer, the first thing you notice is not a pull or a tug, but a profound, unshakable sense of calm. Because you are in free fall, you are weightless, floating in the center of your craft, just as an astronaut does in orbit around the Earth. There is no wind, no rumbling, and no physical sensation of falling. You are simply following the path that space-time has offered you. Ahead of you, the black hole does not look like a swirling drain or a tunnel of fire. Instead, it appears as a perfect dark sphere, an absolute void that seems to expand to fill your field of vision. It does not radiate darkness, it simply refuses to emit light, a silent ghost in the fabric of reality. But as you watch the stars around the edges of this void, the universe begins to reveal its true, warped nature. Light from distant galaxies, which should be traveling in straight lines, is being captured and bent by the immense gravitational well ahead of you. You see stars duplicated, stretched into glowing arcs, and swirling in a cosmic rosette around the central darkness. This is gravitational lensing, a visual confirmation of Einstein's prediction that mass does not just pull on objects, but reshapes the very geometry of the space through which light must travel. You check the instruments inside your cabin. Your clock is ticking with a steady, rhythmic pulse. Your heartbeat is normal. Your breath is slow. If you were to speak, your voice would sound exactly as it always has. This is the first layer of Einstein's peaceful lie, proper time. No matter how extreme the gravity becomes, your personal experience of time remains consistent and unremarkable. You feel a sense of confidence in the laws of general relativity, for everything is unfolding exactly as the equations predicted. The no-drama condition is being met. Because this is a supermassive black hole, the gravitational gradient is so gentle that you feel no discomfort, no sudden jolt, and no stretching of your limbs. The tidal forces, which would shred a human being near a smaller black hole, are spread across a region so vast that for now, they are imperceptible. As the dark horizon approaches, you look back at the universe you are leaving behind. A remarkable transformation is occurring. Because you are accelerating toward the black hole at incredible speeds, the light from the outside world is being blue-shifted, compressed into shorter, more energetic wavelengths. The stars behind you, once scattered across the sky, appear to gather into a shrinking, brilliant circle of light, as if the entire universe is being funneled into a single window overhead. In this window, you witness something that feels like a divine secret. The outside universe is beginning to fast forward. Because of gravitational time dilation, while minutes pass for you, years, decades, and even centuries are unfolding in the world you left behind. You see the life cycles of stars accelerate. You see galaxies collide and merge in what looks like a frantic, beautiful dance. You are witnessing the entire future of the cosmos compressed into your final moments of travel. Then comes the moment of the crossing. You watch your sensors for a flicker, a ripple, or a spark to mark the event horizon, the Schwarzschild radius. But there is nothing. You pass through the most absolute border in the universe without even noticing that you have left our reality behind. There is no wall of fire, no physical membrane, and no sudden change in the vacuum. The space here is as empty and silent as the space you moved through an hour ago. Einstein's theory holds firm. The horizon is not a physical place you can touch, but a geometric consequence of the way space and time are woven together. To you, the traveler, it was a non-event, a silent threshold passed in a state of weightless peace. Now inside, the geometry of your world has shifted in a way that your senses cannot yet grasp. Beyond the horizon, the roles of space and time have effectively traded places. The inward direction toward the center is no longer just a path you are taking, it has become as inevitable as the forward flow of time. You cannot choose to stop moving inward any more than you could choose to stop moving toward tomorrow. Every path available to you, every beam of light you might fire from your flashlight, now curves relentlessly toward the singularity. Yet, within your cabin, everything still feels stable. You are still floating. Your clock is still ticking. You could almost believe that you are safe, that the stories of destruction were exaggerations, and that the point of no return is merely a mathematical curiosity that does not apply to your physical reality. You feel a profound sense of accomplishment. You have done the impossible. You have entered a black hole and survived. You are an inhabitant of a new region of the universe, a place where the laws of general relativity continue to provide a smooth, predictable environment. This is the ultimate comfort of the classical model, the promise that the universe is a continuous, logical fabric that does not break, even at its most extreme edges. You settle into the weightlessness, watching the last sliver of the outside universe's light fade into a distant, blue-shifted spark, confident that your journey will continue in this same, unhurried peace until you reach the center. But this confidence is the final part of the lie. We have built this narrative of a peaceful lie to show how perfectly our current theories of gravity can mask a looming catastrophe. While Einstein's smooth geometry has guided you this far, it is about to collide with a reality that relativity cannot explain. Beneath the silence of your cabin, a hidden war between the smooth paths of gravity and the jagged requirements of quantum information is about to erupt. The no-drama crossing you just experienced is not a settled fact of nature. It is a point of contention that threatens to burn the very fabric of spacing you are currently resting in. You think you are safe because the crossing was quiet, but you are about to discover that the universe may have hidden a lethal trap exactly where we thought reality was at its most serene. We return now to that moment of silent crossing, the weightless peace you felt as you drifted through the Schwarzschild radius of a supermassive giant. In our last journey, we accepted Einstein's no-drama prediction, the idea that the event horizon is a non-event, a gentle marker in the dark that feels like nothing at all. But while you were resting in that weightless silence, a scandal was brewing in the heart of theoretical physics, one that threatens to turn your peaceful drift into a sudden, violent incineration. This is the Amps paradox, a revelation so disruptive that it transformed the event horizon from a passive geometric ghost into an active, high-energy wall of fire. It suggests that the universe has hidden a lethal trap exactly where we once thought space-time was at its most serene. To understand why your peaceful crossing might be a lie, we have to look at the three cherished rules of the universe that physicists realized cannot all be true at once. The first is the idea that quantum information is never destroyed, a principle known as unitarity. The second is the belief that the laws of physics should work normally near the horizon, according to effective field theory. And the third is Einstein's no-drama rule, the promise that a falling observer feels nothing unusual at the edge. For decades, we believed we could keep all three, but in 2012, 4 physicists, Almheri, Marolf, Polchinski, and Sully, proved that if we want to save the information of the universe, one of these rules has to die. The conflict begins with the way black holes evaporate through Hawking radiation. As we've explored, the vacuum of space is never truly empty. It is a bubbling sea of virtual particles that constantly appear in pairs, only to vanish an instant later. Near the event horizon, these pairs are torn apart. One particle falls into the abyss, while its partner escapes as radiation. For this radiation to be normal, the particle that escapes must be mysteriously linked or entangled with the particle that fell in. They share a quantum bond that ignores the distance between them. However, as the black hole continues to shrink and age, it releases more and more radiation into the distant universe. Quantum mechanics demands that to preserve the total information of the system, the newly escaping particles must also be entangled with the radiation that left the black hole a long time ago. This creates a crisis of quantum monogamy. In the world of the very small, a particle is only allowed to be perfectly entangled with one partner at a time. It cannot be married to the particle falling into the black hole, and simultaneously married to the old radiation drifting in far-off space. This is where the peaceful lie of relativity collapses. To solve the crisis and keep the information of the universe safe, the bond between the escaping particle and the interior of the black hole must be severed. But breaking a quantum entanglement link is not a quiet affair. It is an act of extreme violence. Breaking that bond releases a devastating amount of energy, and because this happens at every point across the entire horizon, the result is a literal wall of high-energy particles, a firewall. Imagine again your journey into the supermassive void. In the classical story, you were prepared for a smooth transition, a weightless glide into the dark. But if the firewall theory is correct, the moment your sensors reach that mathematical line, the silence is replaced by an instant, blinding incineration. You do not fade away like a ghost. You are vaporized by a curtain of extreme radiation, exactly where relativity predicted empty space. The point of no return is no longer a coordinates-based illusion. It is a physical barrier of fire that annihilates you before you can ever see the interior. This is the firewall scandal, a paradox that has horrified the physics community because it directly violates Einstein's equivalence principle, the very foundation of our understanding of gravity. If the firewall exists, it means that a freely falling observer does experience something dramatic at the horizon, even if the black hole is large enough to be gentle. It implies that space itself is not smooth, but is instead jagged and broken at the edge. The event horizon is transformed from a no-drama threshold into a scandalous border, where the smooth geometry of general relativity crashes into the fiery requirements of quantum mechanics. As you drift in this thought, consider the psychological weight of this realization. We once viewed the event horizon as a peaceful end, a place where one could simply slip out of the universe's view. But if the firewall is real, the edge is active and violent. The horizon is not a shadow, it is a surface of conflict where the universe is desperately trying to balance its books. To preserve the information of the past, the universe must sacrifice the smoothness of the present. It is a high-energy trapdoor hidden in the dark, a final, lethal defense mechanism of nature that prevents anyone from ever truly knowing what lies within. This reveal shatters our confidence in the simple, one-way door narrative. It suggests that we were wrong about the event horizon because we assumed it was passive. We thought it was just a place where things went to be forgotten, but the firewall tells us that the horizon is where the universe works the hardest to remember. It is an encoded, energetic surface that protects the consistency of reality at the cost of the observer's life. The peaceful lie of the smooth crossing was a luxury we can no longer afford if we want the laws of quantum mechanics to remain intact. The firewall is more than just a theoretical nightmare. It is a mirror, reflecting the limits of our own models. It shows us that when we try to combine our best theories of the very large and the very small, the place they meet, the event horizon, is not a place of agreement, but a place of war. It is the ultimate test of whether our laws of physics are a single, unified tapestry or just fragments of a picture we have yet to see whole. You are no longer falling into a quiet abyss. You are approaching a cosmic barrier that might be the most violent location in existence. In the coming chapters, we will explore even stranger possibilities, that perhaps this wall of fire is not a wall at all, but a tangled web of strings that replaces the interior entirely. But for now, we must sit with the scandal of the edge. The event horizon, once a mathematical ghost, has become a physical wall of flame. The no-drama crossing is gone, replaced by the realization that to reach the point of no return, you must first survive the universe's most energetic defense. We were wrong about the silence of the edge, for the border is not just a place where escape is impossible, it is where the very fabric of reality is screaming to keep itself together. If the firewall was a scandal, a sudden, violent correction to our understanding of the edge, then what we are about to encounter is a total reconstruction of the black hole itself. Until now, we have been operating under the assumption that a black hole is mostly empty space. We've imagined it as a dark, hollow shell with a tiny, infinitely dense point of destruction at its center. This is the sinkhole model of the universe, where the event horizon is merely the rim of the pit. But as we sit with the unsettling heat of the firewall, a new, radical alternative emerges from the world of string theory, a proposal that suggests our very idea of an interior is the ultimate misunderstanding. This is Samir Mathur's fuzzball theory, and it posits that the reason we were wrong about the event horizon is that the horizon, as we define it, does not actually exist. To grasp the fuzzball, we must first look at the no-hair theorem, a long-standing principle that has shaped how we view black holes for decades. The theorem suggests that black holes are incredibly simple, characterized only by their mass, spin, and charge. To the outside universe, they have no hair, no distinguishing features, no textures, and no complexity. But this simplicity is exactly what led to the information paradox. If you throw a masterpiece of literature, a complex computer, or a living being into a classical black hole, all that complex information is supposedly crushed into a singularity and lost. String theorists like Mathur argued that this couldn't be right. Nature doesn't like to delete its own data, and so they looked deeper into the fundamental building blocks of reality to find a different answer. In the world of string theory, everything in the universe, every electron, every photon, every thought you've ever had, is made of unimaginably tiny, vibrating loops of energy, called strings. These strings vibrate in different patterns to create the particles we see, like a cosmic orchestra playing the notes of reality. When a star collapses, the traditional view says it crushes these strings into a single point of infinite density. But Mathur proposed that the strings don't just sit there and get crushed. They get tangled. They grow, they stretch, and they weave themselves into a complex, multi-dimensional web. Instead of a singularity, the collapse creates a fuzzball, an enormous, dense, and solid-ish quantum object made of strings and brains. This changes everything about your journey toward the abyss. In the peaceful lie of general relativity, you were floating through a vacuum, passing a geometric ghost. But in the fuzzball reality, the point of no return is not a coordinate in empty space. It is a physical collision with an ultra-complex quantum surface. The event horizon is no longer an invisible line. It is the actual surface of the fuzzball itself. Imagine a room you thought was empty, only to turn on the light and realize the room is packed floor to ceiling with a dense, vibrating web of yarn. You haven't fallen into a pit, you have collided with the weave of the universe. This creates a new kind of polite horror for our science for sleep narrative. The horror is not in the fall, but in the realization that there is no inside to a black hole in the classical sense. There is no empty space beyond the horizon where you can drift and wonder. There is no singularity waiting at the end of a long tunnel. There is only the fuzz. When you cross the horizon of a fuzzball, you are not entering a new region of space-time. You are being absorbed into a dense, high-dimensional structure. Your own strings, the very things you are made of, begin to tangle with the strings of the black hole. You don't pass through a ghost, you become part of the archive. This is why the fuzzball theory is so attractive to many physicists. It replaces the iconic empty black hole image with something much more physical and information-rich. The surface is sized exactly where we thought the event horizon was, but it functions as a literal storage device. Every bit of information that ever fell into the black hole is written directly onto this surface, stored in the complex vibrations of the strings. In this view, a black hole is not a grave, it is a star made of information. It is an object so dense and so complex that it has fundamentally changed the state of spaceme, turning a three-dimensional volume into a multi-dimensional weave of data. Consider the psychological weight of this reconstruction. We are used to the idea of a black hole being a void, a place of absence. The fuzzball tells us that a black hole is a place of extreme presence. It is the densest concentration of somethingness the universe allows. When we looked at the event horizon and saw nothing, we were like people looking at the surface of a deep, dark ocean and assuming the water wasn't there because we couldn't see the bottom. But the water is the black hole. The fuzz is the reality. The event horizon is simply the edge of the material, the boundary of the weave. This also elegantly addresses the paradoxes of the past. Why does the black hole have entropy? Because the strings on its surface can be arranged in a near infinite number of ways. Why is information preserved? Because it never actually reaches a singularity. It stays right there, vibrating on the surface of the fuzzball. And the firewall we discussed? In the fuzzball model, the drama of the crossing is explained not as a wall of fire, but as the physical impact of hitting a quantum surface. You are annihilated not by a paradox, but by a collision with the most complex object in existence. As you drift in this thought, the silence of the void takes on a new texture. It is no longer the silence of emptiness, but the silence of an overcrowded library. The dark sphere ahead of you is not a hole in the universe. It is a solid, vibrating mass of cosmic data. You are approaching a boundary where the point of no return is actually the point of integration. If you were to touch the surface of a fuzzball, you wouldn't feel a vacuum or a ghost. You would feel the collective vibration of every star, every planet, and every atom that has ever been claimed by this monster. You are moving toward the ultimate archive of the galaxy. This is where we must let go of our classical maps. The Schwarzschild radius was a beautiful, geometric dream, a way to make sense of the abyss using the simple tools of gravity. But the fuzzball reveals that the dream was too simple. We were wrong about the event horizon because we couldn't imagine that the vacuum itself could be replaced by something so intricate. The border is not a vanishing line, it is the most physical place in the universe. It is where space ends and the weave begins. As we settle into this new physical reality, we begin to see the black hole not as a prison, but as a storage device of unimaginable capacity. This realization leads us naturally to an even stranger possibility, one that suggests that if the surface of the black hole is where all the information lives, then perhaps the entire 3D world we thought we were entering is nothing more than a projection of that data. If the fuzzball is a hard drive, then what is the reality it encodes? We have dismantled the myth of the void and replaced it with the reality of the fuzz. We have seen that the crossing is a collision and the horizon is a surface of information. But as the strings of our own existence begin to vibrate in sympathy with the abyss, we must ask, if everything is written on the edge, is there even a center to move toward? Or is the edge of the black hole actually the place where the entire universe is being recorded? If the fuzzball theory offered us a black hole made of physical strings, we are now forced to look even deeper, past the vibrations and the tangles, into the very nature of the data itself. We have been taught to visualize a black hole as a three-dimensional volume, a great hollow sphere with a mystery hidden at its core. But as we settle into the quiet realization that the surface of the black hole is where the information lives, a radical and unsettling possibility emerges from the equations. It suggests that the event horizon is not just a boundary of gravity, but the universe's most efficient hard drive. In this view, the point of no return is actually the place where reality is written. This is the holographic principle, and it proposes that the three-dimensional interior we thought we were entering is nothing more than a magnificent, emergent illusion, reconstructed from data sitting on a two-dimensional edge. To understand why this is more than just a mathematical curiosity, we must look at a strange rule that black holes follow, a rule that breaks everything we know about how objects store information in our daily lives. Think of a normal library. If you want to know how many books you can fit inside it, you look at the volume of the room, the height, the width, and the depth. In our 3D world, information capacity is almost always tied to volume. But black holes are different. In the 1970s, researchers discovered that the entropy of a black hole, the measure of its total internal information, does not depend on its volume at all. Instead, it is proportional to the surface area of its event horizon. It is as if you had a library where the number of books it could hold was determined not by the space inside the room, but only by the surface area of the wallpaper on the walls. This discovery sent a shockwave through the foundations of physics. It implies that every bit of information that ever fell into the black hole, the color of a star, the trajectory of a particle, the history of a planet, is not stored inside the abyss. It is imprinted pixel by pixel onto the two-dimensional skin of the event horizon. We are talking about information storage at the most fundamental level imaginable, the Planck scale. Imagine the surface of the horizon covered in tiny microscopic tiles, each one a trillionth of a meter wide. Each of these tiles carries a single bit of information, a cosmic 1 or 0 that records a fragment of the fallen reality. The event horizon is not a void, it is a high-resolution 2D storage sheet, a cosmic parchment where the universe archives everything that general relativity claimed was lost. As you drift with this thought, the psychological weight of the point of no return shifts once again. We have been viewing the journey into a black hole as a descent into a place. But if the holographic principle is correct, the inside is redundant. If all the information needed to describe the three-dimensional interior is already written on the two-dimensional surface, then the interior space itself may be a projection, a holographic image generated by the data on the edge. Think of a credit card hologram. To your eyes, it looks like a three-dimensional image with depth and structure, but you know that the actual information is stored on a flat, two-dimensional piece of plastic. In the same way, the vast, dark volumes of a black hole might be a readout of the information stored on the horizon. This creates a profound sense of scale horror that is quiet and clinical. If the interior of a black hole is a projection, what does that say about the traveler who crosses the threshold? In the classical story, you are a 3D being moving through a 3D space. But in the holographic reality, as you approach the horizon, your three-dimensional existence is being flattened and encoded onto the surface. From the perspective of the outside universe, you never actually fall in. Instead, you are smeared across the horizon, your entire life and structure converted into 2D quantum data. You become a part of the archive, a bit of code written into the fabric of the border. The point of no return is simply the moment your 3D story is translated into the 2D language of the horizon. This reframing offers a potential solution to the information paradox that haunted Hawking for decades. If the information never truly enters a pit or reaches a singularity, then it can never be truly destroyed. It stays right there, on the surface, accessible to the outside world in the form of subtle quantum patterns. When the black hole eventually evaporates through Hawking radiation, it isn't just losing mass, it is reading back the data from its surface, releasing the scrambled remains of everything it ever consumed back into the cosmos. Nothing is lost, because nothing was ever truly inside to begin with. The event horizon is the ultimate protector of cosmic memory, a hard drive that refuses to let a single bit of reality go unrecorded. But this realization carries a haunting implication for the traveler. If you are inside the black hole, and the interior is merely an emergent illusion reconstructed from data on the edge, then the space you are moving through isn't real in the way we usually define it. You are like a character in a film, convinced of the depth of the world around you, unaware that the entire reality is being projected from a flat reel of film elsewhere. The point of no return is the moment you leave the source universe and enter the projection. The silence of the cabin, the steady tick of your clock, and the inward paths of gravity are all part of a beautifully consistent simulation generated by the bits of information vibrating on the horizon behind you. This leads us to a deeper, more philosophical mystery. If black holes, the most extreme environments we can study, are holographic, then what about the rest of the universe? Some theorists suggest that the entire cosmos might follow this rule. Perhaps the three-dimensional world we inhabit right now, the stars we see, and the ground we walk on are all emergent projections of two-dimensional data stored on a distant boundary at the edge of the universe. In this view, the event horizon is not an anomaly of physics, but a revealing mirror that shows us the true information-based structure of all reality. We are 3D shadows of 2D data, living in a world woven from bits and pixels of information. The universe's hard drive is a narrative of integration rather than destruction. It tells us that we were wrong about the event horizon because we were thinking in too many dimensions. We wanted it to be a hole in space-seam, but it is actually the place where space-seam is created. It is the most dense concentration of somethingness allowed, a place where the universe works the hardest to keep its books balanced. As you continue your weightless drift into the heart of the abyss, remember that you are not falling into a void. You are moving deeper into the data. The darkness ahead is not empty, it is a reconstruction. But as the strings of your existence begin to vibrate in sympathy with the archive on the horizon, we must confront a new barrier. Even if the information is preserved on this cosmic hard drive, it is not easily read. It is scrambled, hidden behind a maze of complexity so vast that it creates a new kind of horizon, one that is not built from gravity, but from the sheer difficulty of knowing thee. Truth. The point of no return is about to be reframed one last time, not as a physical limit of motion, but as a computational barrier that nature uses to hide its deepest secrets. As we settle into the quiet realization that the surface of the black hole is where the information lives, we find ourselves drifting toward a new and perhaps more unsettling barrier. We have been taught to view the event horizon as a wall of gravity, a physical limit of motion where the escape velocity simply becomes too high for light to climb out. But as we peel back the layers of this cosmic enigma, we discover that the point of no return may not be a limit of physics at all, but rather a limit of complexity. This is the computational horizon, a theory that suggests the universe does not just trap information, it hides it behind a maze of such staggering intricacy that it becomes, for all practical purposes, erased. In this view, the edge of a black hole is not where space ends, but where the ability to know the truth becomes impossible. Imagine again the archive we discovered on the holographic surface of the horizon. If the event horizon is indeed the universe's most efficient hard drive, then every bit of your story, every atom of your being, and every memory you carry is written into those microscopic Planck-scale pixels. In a world governed by the laws of quantum mechanics, this information must be preserved. It must, in principle, be recoverable. But being recoverable is a very different thing from being readable. This is where the narrative of the simple trapdoor fails us. We once thought the information was lost because it was crushed into a singularity, but the information maze suggests that even if the data remains right there on the surface, the process of extracting it is so computationally difficult that the black hole itself will evaporate long before we could ever decode a single word. To understand this intellectual barrier, consider the work of physicists Harlow and Hayden, who introduced the computational angle to the information paradox. They proposed that if you wanted to retrieve the information you dropped into a black hole by collecting the Hawking radiation it eventually emits, you would face a task of unimaginable proportions. Hawking radiation, as we have seen, appears to be completely random, like a thermal glow with no discernible pattern. But quantum mechanics insists that the information is hidden within the subtle correlations between those outgoing particles. The trap is not that the information is gone, but that nature has scrambled it into a state of complexity so high that decoding it would require a computer the size of the universe itself. This is the computational barrier, the realization that the information paradox may be technically solvable but physically inaccessible. It is as if you had a library where every book has been put through 1,000 industrial shredders and the resulting strips of paper have been scattered into a hurricane. Technically, the words are still there. Technically, if you could track every atom of paper and every drop of ink, you could reconstruct the book. But if the task of reconstruction takes longer than the lifespan of the library itself, then the information is, for all human and cosmic intents, destroyed. The event horizon is thus reframed as a practical computational barrier, a point where nature hides the truth behind complexity itself. As you drift in the weightless silence of your cabin, this realization adds a layer of polite horror to your journey. You are not just falling into a pit of gravity, you are falling into a state of being where you become part of the noise. Your 3D existence is being flattened into 2D data, but it is not being filed away neatly. Instead, it is being merged, tangled, and scrambled with the information of every star and every atom that has ever crossed this path before you. The point of no return is the moment your complexity exceeds the universe's ability to decode you. You are becoming a bit of code in a hard drive that is technically solvable but physically inaccessible, a ghost in a machine that has no interface for the living. This shift in perspective is intellectually beautiful because it suggests that nature uses complexity as a defense mechanism. The event horizon is a mirror reflecting the broken limits of our own models, showing us that our desire for a clean line was always a misunderstanding of how the universe protects its deepest secrets. We wanted the border to be a physical wall we could understand, but instead, it is a maze where the paths are not made of space, but of logic and data. The reason you cannot return from a black hole is not just that you cannot move fast enough to outrun gravity, but because you cannot think fast enough to outrun the scrambling of your own information. Think of the psychological tension this creates for the observer watching from a distance. They see you freeze at the edge, fading into a red-shifted ghost as your time stretches toward infinity. But they are also watching you undergo a process of total information integration. To them, you are being written onto the horizon's surface, pixel by pixel, becoming part of the massive, swirling archive of the galaxy. They might hope that one day, as the black hole slowly breathes out its Hawking radiation, your story might be told again. But the computational horizon tells them the truth. Even if they collected every photon of that radiation for 1 trillion years, the complexity of your reconstruction is a wall that no mind can climb. This brings us to a deeper, more philosophical reflection on the nature of the void. If the point of no return is actually a point of no computation, then the event horizon is the ultimate marker of the limits of human knowledge. It is where the universe says no further, not to our bodies, but to our understanding. We are 3D shadows of 2D data, living in a world woven from bits and pixels, and the black hole is the place where those pixels are recycled into a form we can no longer recognize. The darkness ahead of you is not empty. It is a reconstruction of everything that has come before, hidden behind a maze of data that ensures the archive remains forever sealed. As you settle into this calm, clinical realization, the silence of the void feels a little more structured and the darkness a little more meaningful. You are not merely a victim of gravity, you are an entry in the most complex ledger in existence. The comfortable myth of the border was a story we told ourselves so we could sleep, a way to believe that the universe was simple enough to be mapped with a single line. But the reality is a battlefield of information, a place where general relativity's smooth geometry crashes into the jagged, fiery world of quantum complexity. You are passing through a vanishing border, a mathematical shadow that only exists as long as we believe our current theories are complete. We were wrong about the event horizon because we wanted it to be a physical destination. We wanted a point where the math stopped and the mystery started. But the deeper we look, the more we find that the horizon is an active, violent, and highly complex surface that challenges the very idea of what is real. It is a mirror reflecting the fact that our most foundational knowledge of the universe is built on a border that might not even be there in the way we imagined. And as you prepare to leave the comfort of this computational maze behind, you must confront the final, perhaps most disturbing possibility that this absolute prison might not even be permanent. We now reach the most radical turn in our journey, a moment where we must confront the possibility that the very subject of this exploration, the event horizon itself, is a disappearing act. For nearly a century, we have treated the horizon as the ultimate, eternal fortress of the cosmos, an unshakable boundary that stands as a permanent monument to gravity's victory over light. But toward the end of his life, Stephen Hawking, the man who perhaps understood these monsters better than anyone, proposed a final, startling revision to his own legacy. He suggested that true event horizons may not even form at all. If he was right, then the point of no return is not an absolute end, but a temporary state, a long and complex pause in the story of matter that eventually, inevitably, comes to an end. To understand this, we must look at the technical distinction that almost every other documentary ignores, the difference between a true event horizon and an apparent horizon. In the classical view of general relativity, an event horizon is a global, eternal structure. It is a boundary that separates the inside from the outside for all of time. As we have explored, this makes it teleological. You only know a true horizon exists if you can see the entire future of the universe and verify that nothing ever escapes. But Hawking realized that in a universe governed by quantum mechanics, the idea of an eternal perfect trap is fundamentally incompatible with the way nature actually behaves. Because black holes are not eternal, because they slowly bleed away through Hawking radiation, the boundary that surrounds them cannot be a permanent seal. Instead of a true event horizon, Hawking proposed that we are looking at an apparent horizon. To the observer floating outside, an apparent horizon looks and behaves exactly like the point of no return we have spent hours describing. It bends light into circles, it slows time to a crawl, and it swallows everything that drifts too close. But unlike the true horizon, the apparent horizon is a local, temporary, trapped region. It is a right-now boundary rather than a forever boundary. It is like a weather system, a powerful storm in the fabric of space that traps light and information within its swirling winds for a time, but one that is destined to, eventually, break apart and release everything it has held. This realization transforms the point of no return into a misunderstanding of cosmic proportions. If there is no permanent event horizon, then there is no region of the universe that is truly, fundamentally isolated from the rest of reality forever. The information paradox that has haunted physics for decades, the fear that a black hole is a cosmic delete button, begins to lose its sting. If the horizon is merely apparent, then the return is not impossible. It is simply delayed by a timescale so vast it exceeds the lifespan of the stars. Nothing is ever truly lost forever. The story of everything that falls into the abyss is merely being held in a state of extreme, scrambled complexity, waiting for the long, slow evaporation of the black hole to carry it back into the light. This creates a sense of polite horror and quiet relief in our narrative. The horror lies in the duration of the wait. For a supermassive black hole, the evaporation process, the long goodbye, takes a number of years represented by a 1 followed by nearly 100 zeros. This is the ultimate fast-forward of the cosmos. As you drift within the apparent horizon, the universe outside is racing toward its end. You are witnessing the entire future of the stars and galaxies compressed into what feels like a steady, unhurried drift. But the relief comes from the fact that the prison is not absolute. The boundary is a temporary illusion, a ghost of a wall that we mistook for a permanent reality. Think of the event horizon now as a pause in the flow of information. In our daily lives, we are used to information moving at the speed of light, flashing across the world in an instant. But at the edge of a black hole, that flow is jammed. The information is not destroyed, it is merely caught in a massive gravitational traffic jam that lasts for eons. The apparent horizon is the marker of this delay. It is a region where the universe has simply changed its mind about where light can go for a while. But eventually, as the black hole shrinks and its temperature rises, the jam breaks. The scrambled bits of your story, once written onto the holographic surface of the horizon, are finally read back into the universe as Hawking radiation. This disappearing act of the horizon changes how we must view the traveler's experience. We previously imagined a firewall or a collision with a fuzzball, but if the horizon never fully forms, the crossing becomes even more spectral. You are passing through a region that is technically solvable, but physically inaccessible. You are moving through a mathematical shadow that only appears solid because of our own limited perspective. The event horizon is less of an astrophysical object and more of a mirror reflecting the broken limits of human models. We wanted the border to be simple, but nature chose complexity instead. This leads us to the final, unsettling truth of Hawking's later years. If true event horizons do not exist, then black holes are not graves. They are, instead, the universe's most patient storage devices. They are places where the fabric of reality is held in a state of suspended animation, protected from the passage of time by the very gravity that seems to destroy it. The absolute isolation we once associated with the point of no return is a temporary illusion, a misunderstanding of a boundary that we thought was a physical wall, but was, actually, just a long, beautiful pause. As we prepare to close this exploration, we must sit with this image, a universe where nothing is ever truly deleted, and where the most famous border in existence is a vanishing ghost. The point of no return is not a destination you arrive at, it is a limit of our own ability to see the future. We were wrong about the event horizon because we wanted it to be an end, but it turns out to be a reconstruction. It is where every major theory of reality begins to disagree, and in that disagreement we find the true nature of the abyss. As we reach the conclusion of our journey, we find ourselves not at a destination, but at a mirror. We have spent a century staring into the dark, trying to name the border between the known and the lost, only to find that the border is a reflection of our own limitations. Throughout these chapters, we have dismantled the comfortable myth of the one-way trap and the clean, mathematical line where space ends and mystery begins. We have unlearned the simple textbook claim that nothing escapes, replacing it with a battlefield of competing realities where the smooth geometry of the cosmos is torn apart by the jagged requirements of quantum fire. In this final stage of our exploration, we must sit with the realization that the event horizon is not a physical place you can touch, but a vanishing border that only exists as long as we believe our current models are complete. It is the ultimate cosmic enigma, a threshold that forces us to confront the fact that our most foundational knowledge of the universe is built on a border that might not even be there in the way we imagined. When we began, we sought the point of no return as if it were a solid landmark in the void. But as we have peeled back the layers of Schwarzschild geometry and Einstein's peaceful lie, we have discovered that the event horizon is fundamentally teleological, a structure defined entirely by the end of time. This is the most profound scale horror of the abyss, the realization that you could be inside a black hole right now and have no physical way to verify your own position within. The causal structure of the present. The horizon is a mathematical bookkeeping tool, a shadow cast backward from future infinity onto our current reality, tracking what might happen in the future rather than what is occurring in this moment. It is a mathematical ghost that exists only in our models of the future, refusing to be touched by human hands or detected by human instruments. This ghostly nature is why the event horizon has become the site of a great intellectual war. We have seen the no-drama promise of general relativity collapse into the firewall scandal, where the quiet, weightless drift of a traveler is replaced by a sudden, violent incineration. We have explored the possibility that the interior is not a hollow void, but a fuzzball, a star made of information where the crossing is not a fall through empty space, but a physical collision with a tangled web of strings. We have considered the holographic principle, which suggests that the three-dimensional space you feel around you is merely a magnificent emergent illusion reconstructed from two-dimensional data sitting on the edge of the abyss. And we have confronted the computational horizon, where the return is not forbidden by the strength of gravity, but by a level of complexity so high that nature uses it to hide the truth from us forever. Each of these theories offers a different version of the truth, yet they all point toward the same unsettling conclusion: the event horizon is where our certainty dissolves. It is the place where physics raises an eyebrow and asks if we truly understand how the world works. If the horizon is merely an apparent marker, a temporary trapped region destined to evaporate and release its contents, then the absolute isolation we associate with black holes is nothing more than a temporary illusion. The point of no return was a story we told ourselves to make the universe feel structured and predictable, a way to mark where here ends and there begins. But in the light of modern physics, that sharp division has softened into a long, beautiful pause in the flow of information. As you settle into the weightless silence of these final thoughts, you might realize that the event horizon has performed a remarkable service for science. It has acted as a stress test for the entire framework of human thought, exposing the gaps where our theories of the very large and the very small refuse to play nicely together. It is a laboratory for some of the most extreme physics imaginable, a place where the ordinary rules give way to something far stranger. We have used the horizon as a cosmic classroom, learning that space and time are fluid, that light can be rewritten, and that even the universe's most perfect traps might one day fade to nothing. The darkness we see when we look at a black hole shadow is not just the absence of light, it is a visual confirmation of how gravity shapes the void, a mirror reflecting our own struggle to unify the laws of the cosmos. This leads us to a deeper, more philosophical reflection on the nature of understanding itself. Perhaps black holes do not hide the truth, but reveal the limitations of locality, causality, and space-time continuity. We wanted the event horizon to be simple because we wanted the universe to be a continuous, logical fabric that does not break. We wanted a clean line where the math stopped and the mystery started. But the deeper we look, the more we find that the horizon is an active, violent, and highly complex surface that challenges the very idea of what is real. It is a reconstruction of everything that has come before, a cosmic hard drive that refuses to let a single bit of reality go unrecorded, even if that recording is hidden behind. A maze of data we can never decode. The comfortable myth of the border was a narrative of continuity, a promise that space is smooth even at the extreme edges of existence. But we were wrong about the silence of the edge, for the border is where the very fabric of reality is screaming to keep itself together. The event horizon is not an astrophysical object in the traditional sense. It is a vanishing ghost, a mathematical artifact that exists in our models but refuses to be touched by our hands. It is a mirror reflecting the fact that our most foundational knowledge of the universe is built on a boundary that marks the limit of human knowledge rather than the limit of the world itself. We are three-dimensional shadows of two-dimensional data, living in a world woven from bits and pixels, and the black hole is the place where those pixels are recycled into a form we can no longer recognize. As you drift now at the unhurried pace of these final moments, let the certainty of the past drift away like the blue-shifted light of a distant galaxy. The point of no return is not a destination you arrive at, but a limit of our own ability to see the future. We have traced the path from a living star to the quiet emergence of a gravitational boundary, only to find that the boundary is a coordinates-based illusion that only matters to those watching from a safe distance. The isolation we feared is a misunderstanding, a long and complex pause in the story of matter that eventually comes to an end. Nothing is ever truly lost forever, for the universe works the hardest to remember exactly where we thought it was at its most forgetful. The event horizon was supposed to be the cleanest boundary in physics. Instead, we have found a region of extreme presence, the densest concentration of somethingness allowed, where the universe works the hardest to keep its books balanced. It is the ultimate protector of cosmic memory, a hard drive that stores the collective vibration of every star, every planet, and every atom that has ever been claimed by the abyss. If we have learned anything from this journey, it is that the darkness is not empty, it is a reconstruction. The most famous border in the universe is not a point of no return. It is where every major theory of reality begins to disagree.